All right. Thank you, everyone, for coming tonight. We have a pretty good turnout, so I'm going to go ahead and start. I got a tool talk on a tool called Dalton. Before I start, though, a little bit about me. Who am I? I got a couple pets. That's me, my wife. We both love to cook. I love to play guitar, and then that is the active state of my car at any point. That picture was taken yesterday, so it never runs. Outside of that, more of security-focused stuff that I like to do. I guess what I'm going to cover tonight specifically is what is detection engineering. It's a little bit of a preface to why you would use Dalton. Why is detection engineering important? What is good detection engineering? All leading into why we would use Dalton, what it is, how to install it, a few other tools that SecureWorks themselves produce, something called FlowSynth, where you would source PCAPs to use Dalton, creating your jobs, how to read your job reports, and then ultimately creating your own custom rules. So, what the fuck is detection engineering? Detection engineering is the process of identifying threats before they do significant damage. I don't know who wrote this at CrowdStrike. It was on their website. But it checks out. Same with Red Canary. Detector's purpose is to identify interesting events. And then this last one was ChatGPT. I'm not going to read the whole thing because it couldn't shorten it all the way down. I wanted to do it. I did like 4 times. I told it to shorten it like 4 times, and it struggled. So it checks out. It all makes sense. So this is my reminder to take a drink. Everyone can do it with me. We'll have these throughout. Otherwise, I'll go too fast and I'll forget. So why does this matter? As threat actors evolve, their attacks and techniques evolve. You, as blue teamers or detection engineers, need to evolve with them, or you'll fall behind. And malware pops up, 0 days pop up. You're not ready for it, and you won't detect it. That's not good. So my opinion of good detection engineering, emphasis on opinion. I'm not a professional detection engineer. I do it as a community member. I like doing it. But knowing what you need to detect, knowing what threat actors' techniques and tools are actually relevant to you, it kind of depends on the industry you're in. If you're in finance, you don't really care about manufacturing, vice versa. Knowing where to gather your data for detection, best places are things like Twitter, malware feeds, staging your own exploits. If a 0 day comes out, grab some code off of GitHub. If there's no detections for the new 0 day, grab a POC. Run the POC in your environment. Grab a PCAP off of it. You can write a detection for it. You might be the first to do that too. And then begging for samples on the internet. That's my go-to. Everyone does that with samples, but knowing how to balance false positives and false negatives, that I think that's more directed towards people who do this maybe at like an MSSP, more direct, like a Cisco Talos or an ET Labs. When they're writing for their customers, you got to be really careful about false. You don't want false positives triggering on thousands of customers. Whereas maybe if you're doing this in a smaller environment, you can be a little bit more direct. It's really focused in on your environment. And then knowing how to provide context to your alerts. Just like writing code, it's good to leave comments. I know none of us actually do it, but it's good for yourself in the future. It's good for other people who might have to look at it. And it's always the worst thing as someone in a SOC to get an alert and really not know what it does. So what the fuck is Dalton? Dalton is a system that allows a user to quickly and easily run PCAPs against their IDS sensors of their choice. It could be Suricata, it could be Snort. And then recently they added Zeek, which isn't an IDS, but it's like a network transaction logger. You pump that into a SIM, all the same. So you can run these against known rule sets. Again, Cisco Talos, ET Labs, known rule sets, anything out on GitHub that someone has created, or you can make your own rules. Dalton is a web app spun up super easily, all done through containers. I'll kind of go over that here in a second. And it was developed and open sourced by SecureWorks. Why is it named Dalton? This was funny to me. So Dalton was named after Patrick Swayze's character in the movie Roadhouse. That's it. That's why. And then right here is Dalton from Roadhouse. I'm not going to read the quote, but I thought that was funny too. Okay, so why use Dalton for detection engineering, specifically with IDS, IPS rules? Testing rule set coverage against PCAPs. Let's say there is a new 0 day. You grab a PCAP of it, you run it against the rules you're using in your environment, and it doesn't trip. That could be cause for concern. Troubleshooting and developing your own signatures in your environment. You might have samples that you're worried about that haven't hit a public rule set. Making sure that those are working. Testing variable changes. Maybe you're adding more web servers, and you have to add those web server IPs to your IDS config. You can run some known alerts you've received in the past against your new config changes, and if you don't get what you're expecting, there would be a problem. Same with IDS engine behavior. Maybe you're making a jump from an old version of Suricata or Snort to a new version. You want to test that thoroughly before you make the move outside of production environment. This may be a method of doing that. And then ultimately crafting custom PCAPs with FlowSynth. I'll go a little bit more over FlowSynth here in a minute, but it's a super neat tool built right into Dalton. Also made by SecureWorks. Take a drink. All right. So my install, I've installed this a few times over the last year probably. I did one specifically for this talk just to kind of really get my head around it. This is kind of the bare minimum I could get away with, and I wanted to do the bare minimum so it's easily accessible. You could do it in an EC2 instance if you wanted to, but really just latest and greatest Ubuntu, 1 core, 1 gig of RAM, anything that can run Docker, and then I don't go less than 50 gigs of RAM or storage, mostly because you have to fumble around with the formatting of the drive a little bit, and Dalton does get big. The initial build is like 25 gig. So, and you want room for it to grow. So, 50 gig is I wouldn't go less than that. You could if you were limited, but this is the bare minimum I've gotten away with. So install, super easy. I don't know what happened. Oh, there it is. I jumped over it. Super easy. You're pulling down the GitHub repo, you're executing it, and you're waiting about 30 minutes. It takes a long time. It's building like 4, 5, 6 sensors. It's building like 6 containers. It's doing a lot of stuff. The 30 minutes is usually you're sitting, the 1 core, 1 gig of RAM, and all the sensors. That's where you'll get closer to 30 minutes. If you beef it up, you'll get closer to the 15. Just go grab coffee and walk away for a while. Regardless, it'll run itself out. I was apparently needing more than. All right. Okay, so I talked about FlowSynth earlier. I didn't bring anything up about it. So what is FlowSynth? Once again, another tool developed by SecureWorks that they just threw inside of Dalton. It's a tool to rapidly model network traffic, and it can be used to generate text-based hex dumps as well as PCAP files. So why is that important? Why do we care? Let's say you find a sample of malware on Twitter. Pretend the triage link isn't there and you can't go grab it and pull down an actual PCAP. You just have your HTTP header at the bottom here. So you can take this HTTP header, you can take your machine ID, all the header and the body information, and go to the next slide to plug this into FlowSynth. So the idea is you're building a PCAP out of nothing, out of information that you've received from Twitter, from threat feeds, that you don't have actual solid PCAP or sample information on. And ultimately, it builds a PCAP for you. PCAPs are required for Dalton. It's also required just to run against your IDS. So this one, for example, just go back, was a raccoon stealer. A new user agent popped up on it, so it was now unique in the environment. So once you've got your packet, that's the 628 PCAP file up there. You load it in. You run it against whatever rule set you want. Usually the Eve log, other log, the standard logs are good enough for like 99% of people. That's all you're going to care about. You dump it. I need a drink before we see it, apparently. And this is the alert you'll receive. So this is good, right? If you're worried that you're not going to see this in your environment, don't worry, because these are the alerts. They popped. This was for CNC and just Raccoon Stealer in general. So this is just the alerts. I don't see if I go forward. I don't remember if I cover Eve here. I did not. I'll cover Eve here in a minute. Okay, so let's say you don't care about FlowSynth. You don't want to build packets from the ground up like that. Where do I source PCAPs? My favorite places to get PCAPs are Triage, any.run, anywhere, any type of threat feed that has samples or PCAPs. I think VX Underground does PCAPs. Do they? I'm looking at you and you don't know. Okay, they just do samples. People would give you, if you ask. Once again, going back to begging. Yeah, you beg. Threat feeds. So let's say you've run out of options for PCAPs and you just have samples. Create a sandbox or find malware in the, find your samples, run them through things like Triage. Now you can get PCAPs out of them. Or one of my favorite methods is network capturing your exploits out of like Kali while you're doing a try hack me or a hack the box room. I actually did this with Log4j when it came out, and I was learning on a lot of this with Log4j. So I understood how it worked. I saw it in Wireshark, and I kind of got to discover how to write detections through that by doing a try hack me room. So you have your PCAP. It's time to create a job. I'm going to take a drink there anyway. I need another drink. Okay, we kind of walked over this already with the FlowSynth, but you're loading your PCAP. Once again, take a drink every time I say the word PCAP if you don't want to make it out of this talk. But you'll load it in. You're going to pick your sensor. In this scenario, I'm just running the latest version of Suricata. You choose your rule set. This one's just up-to-date ET. If you're running Snort, you'll probably go with Talos. Maybe you have your own in-house. You're big enough to do that. And then you're logging. Once again, the more of these you choose, the longer it's going to take to run, especially if you have a large rule set. But for 99% of the population, once again, Eve and other is all you care about. I didn't go into Eve. I'll explain that here in a second. So it's going to dump your alert. Once again, alert. Smoke loader this time. Smoke loader CNC. And I'll go over to JSON. So here we go. So this is the Eve output. This is what Suricata, this is what Zeek will output that you want to send to a SIM. This is your logging information. This is where the meat is. So you'll see information in here like your destination IPs, your RR names, your queries, whatever it is you're looking for. I didn't filter out for the actual alert in this one, but you can do that. I mean, there's tons of options in here. It's JSON, so you can parse it yourself if you're not interested in sending it through, like an Elastic or a Splunk. So testing custom rules. I think this is the biggest piece of Dalton. This is the most important part of it. You want to, you want to write you want to see an exploit in action. You want to write a detection for it that isn't being captured today. Cool. So it has its own custom rules. You don't have to use defined rules. You can, in this scenario, I created a PCAP on my machine, just let it take random traffic, and then I made a curl request to ifconfig. Drop my super simple alert in here. All I'm looking for is HTTP user agent, content curl. That's all I care about is that curl exists in the user agent. I popped my own alert. That's always good to see when you're writing these. This is my custom alert. There's no info in this alert though, so like I went back earlier to context, this is what you want. But going over, you have more JSON. Once again, send all this to your Elastic, send all this to whatever you want to parse with. Dalton has its own API, so do with it what you want. But, I mean, this is where the meat is. And I think that is a drink time. That might be it. It is it. Questions? I know that was a lot really fast. I tried to slow it down, but... When's the next Cars and Coffee? I have no idea. I don't know that. No other questions? You? I'm sorry. I'm having trouble hearing you. So why should you depend on tell me if I'm rephrasing this wrong. Why should an organization worry about detection engineering over just EDR and SIM? So detection engineering goes with an EDR and a SIM. So maybe you pay, maybe you don't pay a managed service to write your queries for you. Detection engineering is the process of writing an alert, right? It doesn't have to be for an IDS. It could be for endpoint. It can be anything in your SIM. It's just the process of writing and detecting new alerts, new malware, stuff like that. So really, I mean, I would say SOC people, security engineers, maybe higher level SOC people could be learning how to do this, should know how to do this. Usually security engineers, and then in bigger organizations just focused on it are detection engineers. Anyone else? No? All right. Thank you.